Hi everyone, welcome to Robotics Programming with ROS. ROS stands for the Robot Operating System, which is a free and open source library for programming robots. My goal in this video is to show you that you don't need a lot to get started. You just need Ubuntu Linux and some knowledge of programming. And you won't necessarily need a robot to get started because we are going to use a simulated robot that's provided by ROS, which is really good. So I think that robotics is a pretty exciting field to be in right now. Robots have always kind of been in the background, like in factories, automating assembly, but we don't really interact with robots on a day-to-day basis. And I think that's going to change. So, for example, we have the Google self-driving car and many other companies that are working on self-driving cars. I think that's going to become a reality one day. Another robot that we might start seeing in our everyday lives is Amazon Prime Air, which will deliver packages to your doorstep by themselves. And I interned at this company called Saviog, so that the Saviog relay is pictured on the right, and it's an indoor delivery robot. It's right now working in several hotels to deliver room service items up to guests. And it's a really cool robot, and they actually do use ROS there. So what is ROS? ROS is a software framework for programming robots. It was originally prototyped, designed at Stanford AI Research, but it was officially created and developed by this company called Willow Garage starting in 2007. It's currently being developed further and maintained by the Open Source Robotics Foundation. And people who work on ROS like to say that it consists of 4 things: infrastructure, tools, capabilities, and ecosystem. So infrastructure just means in ROS there's going to be a lot of like networking stuff. It's a multi-process, multi-computer architecture, and you don't have to develop any of that yourself. You just get it as part of the library. It also has lots of interesting command line tools that are useful, as well as some great visualization tools. Capabilities are probably one of the reasons why people like to use ROS a lot, which is that it comes batteries included. That means it comes with implementations of lots of common robotics algorithms that every robot needs. And so if you're just getting started programming a robot, you don't need to develop these capabilities yourselves. You can kind of use these and build on them. And finally, because ROS is open source and there's a strong open source community around ROS, there's a big ecosystem. Lots of people use ROS and they share packages and code with each other, and you can take advantage of that. So let's talk about what some of the advantages and disadvantages of ROS are. So on the advantages side, like we just said, ROS has lots of infrastructure, tools, and capabilities. And what this means in practice is that it's very easy to try other people's work and incorporate it into your project. It's also very easy for other people to incorporate your work into their project. So let's say, for example, I want a face recognition system on my robot, and I don't really know how to make a face recognition system, but I know I want it. Well, there are ROS packages that you can use. You just download them, add them to your project, and you get a face recognizer for free. And because they work with ROS, it's very easy to integrate with each other. And like we said, there's a large community of people out there who use ROS. Chances are, if a roboticist doesn't use ROS, they've at least heard of it. And so there's always lots of code, lots of people with different interests working with ROS to do different things. And just another advantage of ROS is that it's totally free to use. It's open source, so you can look at everything about how ROS works, and it has a very permissive BSD license. So I think the takeaway about what the main advantages of ROS are is that it's great for open source developers. It's great if you just want to get started quickly. It's really great for researchers as well. Now, what are some of the disadvantages of ROS? Well, ROS has been out for over 8 years now as of this video, and it's definitely approaching maturity. Like, the difference between different versions of ROS are fairly minimal, but it is still changing. There are lots of APIs that change, and if you have an older robot that maybe isn't caught up to the latest version of ROS, you have to worry about things like which version of Ubuntu do I need to use, which libraries, which versions of different libraries I need to use, and that kind of thing. The other thing is that while it's always possible to build security and scalability around ROS, those aren't really like the primary concerns about what the ROS library gives you. Basically, you have like all this network communication, and it just happens without any like pre-made authentication mechanisms or any pre-made replication or load balancing systems. So those aren't really the main concerns of ROS. And then the only operating system that ROS can currently be used on is Ubuntu Linux. Now that's not totally true. You can use ROS on other operating systems, but they're not supported. And so basically, maybe you can look online and find a tutorial about how to use ROS in Mac OS or something like that, but it's not going to be easy. So I think some of the maybe key takeaways about the disadvantages of ROS is that it's not really the best for tasks which are totally mission critical, totally need to be scalable or secure, or need to run on some kind of operating system other than Ubuntu, which is fairly common. So for example, I wouldn't imagine like writing airplane software with ROS. So in these tutorials, I'm going to focus on explaining all the various ROS concepts, and there's actually quite a few of them, so I'm very excited to make lots of these tutorials for you. And I also want to focus a little bit on the software engineering aspect, so looking a little bit at what tools I like to use personally, unit testing, continuous integration, that kind of stuff. Like I said, we're mostly going to be developing with a robot in simulation called a Turtlebot. I've used this before, and I think that the Turtlebot simulation is very good. It's very fast, and it's pretty close to developing with a real-life Turtlebot. Now, if you want to buy a Turtlebot, you can look online and find them. They cost about $2,000 each, so they're not that cheap. But you do get like a laptop, Kinect sensor, and a mobile base, which does not vacuum, unfortunately, so you'll have to take that into consideration if you want to buy it. I want to do a mix of like explanations, kind of like what I'm doing now, but also doing real coding and showing you guys actual code. Now, what about the official ROS tutorials online? I do recommend checking those out and reading them and doing them, especially for the basic concepts. A lot of my videos are going to be basically rehashes of what you can already find in the tutorials, so I kind of view this as more of a supplement to the tutorials rather than a replacement. But when it comes to some of the more advanced topics, I think the documentation starts to get a little bit thinner, and so hopefully I have more value I can add to you guys once we get to the more advanced topics. So let's talk about what you need to get started with ROS. So for these videos, I'm going to recommend using Ubuntu Linux 14.04. That's because the current version of ROS that's out there is targeted towards this version of Linux. And if you're thinking about maybe using a virtual machine or something like that because you're on Windows or Mac, I don't really recommend it. I think that dual booting into Linux or just installing Linux as your main operating system is the best. And the reason why is because of the second point, which is that you'll want like a fairly recent computer. I'm not going to put any specific numbers on this because I'm not exactly sure what kind of specs you need on your computer. But you know, ROS itself is not going to take up all your RAM or anything, but it's mostly to run the simulation. So if you're going to run the Turtlebot simulator, it's going to take up a bit of time. So the best thing you can do is just try it and see if it feels slow to you or not. But yeah, you probably don't want to use like a netbook or something to develop with. And then in terms of some of the knowledge prerequisites, hopefully you'll have some familiarity with the Linux environment and developing in Linux. So we'll be spending a lot of time in the command line and so on. And then knowledge of programming in C++ and or Python. This is because these are the two main languages that ROS is developed in and uses. There are a few other languages that ROS that can be used with ROS, but they're not officially supported. And so we'll be doing a little bit of both C++ and Python in these videos. Okay, so here we are in Ubuntu 14.04. Like I said earlier, hopefully you're not in a virtual machine and also not booting off of a live USB stick, because we're going to be downloading a lot of stuff. So this is the ROS website, ros.org, and I also have a terminal open. So we're going to go to the install page on the ROS website and notice that there's two versions. So kind of like maybe some other software you've heard of, the different versions of ROS, the first letter of their name increases alphabetically with each version. So we had E for electric, then F for fuerte, then G for groovy, and then H for hydro. And the two current versions are I for indigo and J for jade. So indigo is currently recommended as like the long-term release, and jade is kind of like the cutting edge release. We're just going to go ahead and use indigo. So this is the ROS wiki, and the ROS wiki is kind of going to become our best friend over these videos. So like I said, a lot of these early videos are not going to show you stuff that you couldn't find out otherwise from the ROS wiki. So we're going to go ahead and go through the installation process just by following the instructions here. So first, we're going to want to copy this code. Notice that you will need sudo access to your machine. So if you are on a shared machine and you're not an administrator, then you need to change that. Otherwise, you can't install any of this software. So we're going to do steps 1.2, and now let's do step 1.3. And then we're going to run sudo apt-get update. And some of this stuff is going to take a while, so especially once we get to the real installation. So I might do an edit to just cut away to once it's done. Okay, so that previous step just finished. I paused the video a little bit. So now we're going to keep on going. We just finished 1.4. I forgot to mention, but I do recommend doing the full, highlighting the wrong thing. I do recommend using the desktop full install. This will install most of the tools that we're going to use. These other ones are kind of just like smaller subsets of ROS. So now we're going to continue with further steps. Just make sure you run sudo rosdep init as sudo, but then you don't use sudo when you run rosdep update. In this case, it says that I've already done this because I've already installed ROS on this computer before. So go ahead and just run rosdep update. Okay, so now that we're done with that, now it says environment setup. So this is where it starts to get a little bit interesting. It says that you want to add this line to your bash RC, which is a perfectly reasonable thing to do. The reason why is because we've just installed ROS and we want to try running one of these ROS commands. So for example, one ROS command is just rosnode list or ROS core. Notice that it says command not found. And the reason why this happens is because ROS makes use of a lot of environment variables to configure itself and just get things set up. And so that's basically what this line is doing right here, is that normally we have to source this file, which is located in opt-ros indigo setup.bash. So once you source this file, now you have a bunch of environment variables related to ROS in your environment. And so now if I say ROS core, for example, it actually starts a ROS core. So we'll talk about what that means later. And the reason why you want to have that line in your bash RC is because every time you create a new terminal window, and you will be creating lots of terminal windows when you're programming in ROS, you don't get that kind of thing until you don't get any of the ROS commands until you source the right environment. So this is why you want to have this in your bash RC. So let's go ahead and add this to our bash RC. You can also just run this command that they offer you instead of opening an editor. So this will ensure that for every terminal that you open, you have the right ROS commands available. This terminal won't have it because I added it to the bash RC, but the bash RC did not actually execute. So in order to do that, I need to source my bash RC again, and now I can run the command. So the bash RC is kind of like a configuration file that runs for every new terminal window that you open. You can think of it that way. And then they also recommend a couple of tools that you might as well download, so we can go ahead and download that as well. One tool that I like to use, where I'm going to differ from the ROS tutorials a little bit. If you search for something called Catkin Tools, there's this project called Catkin Command Line Tools, which I really like a lot. And so you can just follow the installation instructions, and I think actually you don't need to do these steps. You can just run this command. Yeah. This is just getting on these are the same commands that you ran earlier. So this will give us access to a slightly different tool that we're going to use later. Okay, so the next step is to actually install the Turtlebot software. So if you do a Google search for Turtlebot install, you'll get to this page that I was just at, Turtlebot installation. So the first section talks about how to install a pre-installed Ubuntu and Turtlebot software directly on a Turtlebot. So that's not what we want to do, so we'll just go ahead and skip that. What we need to do is actually do a package install. So we'll go ahead and copy this line and run it. Okay, so now that the Turtlebot installation has finished, we can actually go ahead and get started. So now we're going to go ahead and run the Turtlebot simulation. So to do this, we're going to run this command, ROS launch Turtlebot, and then I'm going to hit tab twice on my keyboard, and this will show, this is basically tab completion, which is very common in lots of command line utilities, and we can do this for a lot of ROS commands as well. So if I tab complete, we can see all the list of packages that we have that start with turtlebot underscore. And so this is just really helpful for discovering what's available and also to avoid some typing. So what we want is Turtlebot Gazebo. So Gazebo is the name of the simulator that we're going to be using, and we're simulating a Turtlebot, and so that's why this is called Turtlebot Gazebo. And then let's hit tab twice again, and now you can see that there are three options for us. There's AMCL demo, gmapping demo, and Turtlebot World. So we're interested in Turtlebot World.launch, and this will just sort of start a Turtlebot simulation in like a little fun little world for the Turtlebot to explore. We'll get into what ROS launch means exactly and what launch files are exactly, but just to break down this command for you, ROS launch is the command that we're doing. It's going to start up a launch file. A launch file essentially is an XML file that describes different processes that you want to run at the same time, and so you always need to specify a launch file with ROS launch. And what this command in the middle, Turtlebot Gazebo, is, this is the name of the package that this launch file is located in. So basically I'm saying look inside of the Turtlebot Gazebo package for a launch file called turtlebotworld.launch. We'll get into how do you make a package, how do you find packages and stuff like that later, but for now just know that one of the things that we installed just now was this package called Turtlebot Gazebo, and it contains this launch file. So let's go ahead and run it. The first time you run it, it might take a while. I've already run this before, so it probably won't take as long. But yeah, just keep in mind that the very first time you run it, it might show a blank screen and wait for like 30 seconds or something like that before we see something. So this is the Gazebo simulator of the Turtlebot. You can move around in the world, but for me, left clicking will just sort of drag the scene. Middle clicking will actually do like a 3D rotation. I believe control click, no wait, okay, shift click will do the 3D rotation, and then using the mouse wheel will zoom in. So this is how you can sort of look around in the environment. So in the center here is our little Turtlebot, and you can see it's got a pretty nice 3D model, and then there's all these little things around the Turtlebot for us to explore. So now let's actually do something with the Turtlebot. Before we do that, actually, let me talk just a little bit about what this number here, the real-time factor, means. So if you look down here at the real-time factor, it says it's 1. So the real-time factor basically says how fast is the simulation running compared to real time. So some of these simulations are very complex, and so to fully process all the numbers and stuff, it takes more time than the CPU actually has to display it. And so if your real-time factor is below 1, this means that your simulation, the simulated world, is running in a time that's slower than real time. And so you generally want your real-time factor to be 1 or as close to 1 as possible. If you're trying this on an older laptop and you see that your real-time factor is below 1, then that could be a sign that you might want a faster laptop. I generally find it to be quite tolerable to have a real-time factor of maybe like 0.8, and anything below 0.6 would probably be a little too slow for me. But in this case, I'm personally running at a real-time factor of 1, which is good. Okay, so now we're going to run a Turtlebot teleop. This will let us drive the robot around. So to do this, we're going to do the same thing that we did before, ROS launch, and then we're going to specify the name of the package. Let's tab twice, and you can see that we've got Turtlebot teleop as the name of the package here. So we'll go ahead and tab complete that. And then let's go ahead and tab twice again, and you'll see that there are 4 different launch files at our disposal. There's one called keyboard teleop, and some other things, PS3, Xbox 360. So what these are is that basically you can drive around a Turtlebot using a joystick, like a PS3 joystick or an Xbox joystick, and these are just different configurations that allow that. In this case, we want to use the keyboard teleop since we're just at our computers. And now it says control your Turtlebot, and basically these commands just say if you press I, it'll go forward. If you press comma, it'll go backwards. J and L will rotate the robot. So let's go ahead and press I right now. I'm pressing I. And one thing to be careful of is that you need to have this window selected because this is just like a command line application. So you can't select this window and press I. If I press I, nothing is happening. You need to have this window selected. So I'll go ahead and press I. I can press L to rotate it clockwise. Pressing I again. And then there's a pretty fun thing you can do, which is that you can actually increase the speed quite a bit of the robot. So let's go ahead and do that. And now you can see the robot drives a lot faster than it did before. So you can go ahead and just drive it around this cube. And like I said, I think that this is a great simulation of the robot. In our lab, we had 3 of these Turtlebots, and I've done a mix of development in simulation and also on the real robot, and I think that with some simulations you don't get like a really good simulated robot, but this one is pretty good. You can pretty much expect that if something works in simulation, it will kind of work in the real world as well. So you don't have to worry about that too much. Alright, so as you can see, we were able to install ROS, install the Turtlebot software, run the Turtlebot simulation, and drive the Turtlebot around, all using ROS, using free and open source software. So I hope you're very excited to learn more about robotics programming. Please remember to subscribe. I'll post more videos about how to actually write some programs and do interesting things with the robots.